Alright, hi everyone. I'm Ricky and I couldn't find a whiteboard, so I'm just going to have to make this work. My problem is pretty simple. What we're looking at is we have a box here that's being supported by two separate springs. One's a bit larger, and we'll say that that has a stiffness or spring constant of Ka, and then the smaller one on the inside here, has a stiffness of Kb. You can see that. Okay, and then what we're going to want to try and do is find the displacement of the box. Okay, so we do that. First step is to draw a free body diagram and balance our forces. So we've got the box here, and we'll say that it has weight W, and then we've got a infinitely thin plate here that it sits on, and then I'll just draw these. You can see up top here how I showed that the springs are nested inside of each other. So we've got this baby spring inside of this bigger spring. So that's just what I'm showing here from the side. Okay. So now I'm drawing the larger spring, and here's the smaller spring. Okay. So since these are both technically cylinders, we just have two reaction forces. We'll call this reaction force Ra, and this one here Rb. Okay. And then, so we want to balance these forces. So we sum the forces, set them equal to 0. You'll see up here, I said that the going upwards on the page is the positive y direction. So we'll say that you have a positive Ra plus Rb minus the weight of the box. So that means that the weight of the box is equal to Ra plus Rb. And now we will do our force displacement equations, which we're just going to be using Hooke's law for that to relate our forces and our stiffness for the spring, and then how far we're displacing those springs. So using Hooke's law, we have Ra equals Ka delta A, our displacement, and same for the other spring. The reaction force Rb is equal to our stiffness Kb times our displacement. Alrighty. And then now we're looking for a compatibility equation, and it's pretty simple in this case. If we go back up to this drawing, you can see, say we compress this, or if we brought this box down by some amount. So our spring A would be at some original length, and it was compressed, so minus some delta A. And then we can say the same for our spring B. It was at some original length, which was the same as the original length of spring A, subtracting off some delta B. It's pretty evident from this diagram that the compression, or the change in length of the springs, have to be equal. You can show that pretty simply algebraically. So we've got our displacement of the spring A has to equal the displacement of the spring B. Okay. So then we will combine our two Hooke's law equations. We'll add those together. So we have Ra plus Rb is equal to Ka delta A plus Kb delta B. Then if we go ahead and use our compatibility equation, we can say that Ra plus Rb is equal to Ka. We'll just go ahead and call it delta, because delta A equals delta B equals delta, plus Kb delta. Okay, and originally we wanted to solve for the displacement of the box. So we're trying to solve for delta here. So we'll factor out a delta. Ka plus Kb. Okay, so we have delta is equal to Ra plus Rb over Ka plus Kb, and we'll assume that we don't know the reactions and that we know the weight of the box. And so from our force equilibrium equation, we can just say that the total displacement of the box is W over Ka plus Kb, and there is the total displacement of the box. Thanks.